Hello and welcome to the third lesson for outcome 30.5, probability of two events. In this lesson, we are going to focus on what we call independent events. On the rubric, we are going to be able to determine whether things are independent or not. We are going to solve some basic independent problems. We are going to be solving problems that involve two events in this lesson. So again, we're going to understand and solve problems that involve independent events. When we look at our two words again, the or, meaning that we are going to add and subtract in that formula. When we see the word and, we are going to multiply. We are going to focus on that keyword and. So let's try something. So independent events. If the probability of event B does not depend on the probability of the first event, event A, then they're called independent events. For example, if I toss a coin and I draw a card from the deck, they do not change or affect each other. They are independent from each other. The probability that two independent events, A and B, will both occur is basically just the product. I take the probability of A and the probability of B, what they would be separately, and I just multiply them together, and I get my independent event probability. So here's an example. We have Anne and we have Abby. They all have 11 red and 8 blue marbles, 19 altogether. And, if I look at Anne first, she has 2 bags. In bag 1, she has 7 red, and she has 3 blue. And then in bag number 2, she puts all the rest. The 4 remaining red, and the 5 remaining blue. Abby, on the other hand, just has 1 bag where she has her 11 red and she's got her 8 blue. We want to know what is the probability that they're going to get 2 red marbles. Is it going to be the same? So we want to go probability of getting a red, and then the probability of getting a red for both. Probability of getting a red, and then probability of getting a red. So let's start with Anne. So in her first bag, she has 10 marbles, 7 of which are red. In her second bag, she has 9 marbles, and 4 are red. Her probability then is 28 out of 90, which could reduce to 14 out of 45. Abby, on the other hand, she has 11 red out of 19 in her bag. But now that she's taken a red marble out of that first bag, she's only got 18 marbles left. And out of those 18 marbles, only 10 are red. So if I multiply that out, 11 times 10 is 110. 19 times 18 is 342. And let's see if I reduce my fraction that I get the same answer. And I don't. The Abby question is what our last lesson was all about. They were dependent on each other. The first draw was affected by what I got in the first. For Anne, those are independent. What she drew from her second bag was not affected by what was in the first bag. That's the difference between an independent and a dependent event. So let's try this example. Chase estimates that the probability that he's going to pass math, so pass math, is 0.8, and the probability that he's going to pass English is 0.7. Okay, so we have those. Let's figure out the probabilities of failing. So the probability that he's going to fail math is then the rest. You take the full 1, subtract the 0.8, and you get 0.2. Same thing with probability that he's going to fail English. I take my full, which is 1.0, subtract off 0.7. So there's a 0.3, or a 30% chance that he's going to fail English. So A says, what's the probability he's going to pass math and English? Well, passing math and passing English are independent of each other. Just because you pass one subject doesn't mean you're going to pass the other. So if I want to find them both, all I got to do is multiply both of those passes up. I got to multiply pass math, which was 0.8, and I have to multiply pass English, which was 0.7. So 0.8 times 0.7 is 0.56. You can change that to a percentage by multiplying by 100, and you would get 56% chance. B is pass math, but fail English. So he has a 0.8 probability, or an 80% chance of passing math. To fail English, he has a 0.3 probability, which is a 30% chance. So 0.8 times 0.3 is 0.24. If you multiply that by 100, that is a 24% chance that he'll pass the math class, but fail English. To fail both, I just take both of those failure probabilities, 0.2 for math, 0.3 for English. So 0.2 times 0.3 is a 0.06 probability. Times that by 100, it's a 6% chance that he's going to fail both. Again, they're independent because passing one or failing one doesn't necessarily mean you are going to pass or fail the other. Last example for this lesson. This example reads, all 1,000 tickets for a charity raffle have been sold and placed in a drum. There will be 2 draws. First draw for the grand prize, second draw for consolation. After each draw, the winning ticket is returned to the drum so that it might be used again. Max bought 5 tickets. Determine probability to the 10th of a percent that he will win at least 1 prize. So at least 1 prize means that he wins 1 or 2 prizes. So he might win the first prize and then lose the second, or he might lose the first, win the second, or he might win both. So now all I'm going to do is set that up. So out of 1,000 tickets, there's 5 that he has that will win. That ticket gets put back in, so there's still 1,000 tickets in the drum, and all the rest are ones that he will lose. So 1,000 subtract 5 gives me 995. Or he might lose the first one, so 995 out of 1,000. And then there's 5 tickets that he would win if that ticket gets put in. So there's still 1,000 left to pick from. Or he simply could win both. So 5 out of 1,000 he wins. That one gets put back in. So 5 out of 1,000 he wins the next one. And so now all I'm going to do is multiply that out. 5 times 995 is 4975 out of 1,000,000. Same thing over here. And lastly, 5 times 5 is 25 out of 1,000,000. 1,000 times 1,000 And again, that or here and here in between all those cases means that I'm going to add up those answers. So 4975 plus 4975 plus 25 is 9975 out of 1 million. Now this question said to the nearest tenth of a percent, so I need to change it to a percentage. So I will divide. My calculator says 9.975 times 10 to the negative 3. That's the scientific notation. All I'm going to do is take that answer, then I times it by 100, and then I will get a nice percentage. So if I times that by 100, I get 0.9975%. It did say to the nearest tenth, so the nearest tenth is 1 decimal place, so I would round up to 1.0% chance that he will win at least one prize. Now it's time to practice